Hey guys, welcome back to my channel GP Stories. So today we'll be solving Eto numericals. So today's topic is RLC circuits. So before going to RLC circuit problems, we will discuss the formulas which is related with the problems. So it will be helpful for solving the problems. So let's go. So first is L. L means inductance. C means capacitor. This you know it's a basic. XL is inductive reactance, XC is capacitive reactance. So coming to the formula, RLC circuit, XL is equal to 2 pi FL, XC is equal to 1 by 2 pi FC, Z that is impedance, impedance is equal to root of R square plus XL minus XC whole square, cos phi which is the power factor is equal to R by Z, P that is the real power is equal to VI cos phi, Q that is the reactive power is equal to Vi sin phi. Then S is the apparent power is equal to V into I. At resonance, XL is equal to XC, that means that inductive reactance is equal to capacitive reactance. So impedance will be equal to R. F is equal to 1 by 2 pi root of LC. Dynamic impedance is given by L by C into R. Quality factor is given by Q is equal to 2 pi F naught into L divided by R, or Q is equal to 1 by R into root of L by C. So this both formula can be used. So let's go into the problems. Okay, let's do the first problem of RLC circuit. So this is a question given. A coil has resistance of 10 ohm and inductance of 0.15 Henry is connected in series with a capacitor across a 100 volt, 50 Hz supply. If current and voltage are in phase, what is the value of current in circuit? Current in each branch of the circuit, total current, voltage drop across the coil. Okay. So let's read the question again. So coil has a resistance of 10 ohm. So there is a coil which is having a resistance of 10 ohm. Okay, there is a resistance of 10 ohm. Okay, and inductance of 0.15 Henry. So there is an inductance of 0.15 Henry that is connected in series with the capacitor. So there is a capacitor that is connected in series with it across a 100 volt 50 Hz supply. So this is across a 100 volt 50 Hz supply. Okay. A resistor of 10 ohm, a inductance of 0.15 Henry, and a capacitor which is connected across a 100 volt, 50 Hz supply. Okay. If current and voltage are in phase, okay, given current and voltage in phase, voltage in phase, okay, what is the value of current in the circuit? Okay, current in each branch of circuit and total current with the voltage drop across the coil. Okay, so they have given that current and voltage are in phase. By this sentence we can understand that if current and voltage are in phase, it means that it is at resonance. So at resonance we know that XL is equal to XC at resonance. Okay, so if XL is equal to XC, Z is equal to R. Okay, so in this circuit the supply is of 100 volt, 50 Hz. So there is a current that is flowing, I. Okay, so let's find what is given. We'll write R is equal to 10 ohm. Okay, L is equal to 0.15 Henry. Okay, C we don't know how much. We know at resonance XL is equal to XC, that is equal to 2 pi F L is equal to 1 by 2 pi FC. So we have to find C. So C. So we know that XC is equal to 1 by 2 pi FC, or XL is equal to 2 pi FL. So we know the value, that is equal to 2 pi FL, that is 2 into pi into F is given 50 into L is given 0.15. So that will be equal to 47.1239 Henry. Okay, this is a value. So we got XL. So XL is equal to XC. So that is equal to 47.1239. Okay. So we got the value of XL and XC. Now we have to find the value of current. So to find the value of current by Ohm's law, V is equal to I into R. Okay. So here it is not only R, it is, we have the coil, so it will be V is equal to I into Z. Okay. So I is equal to V divided by Z. Okay, we know V is 100 volt. So what is Z? At resonance, Z is equal to R. So it is equal to R. So 100 divided by R. What is R? R is 10. So I is 10 ampere. Okay. So we got the value of I, the current flowing in the circuit, that is the total current. Now we have to find the voltage drop across the coil. So I'll go to the next page. Okay. So voltage drop across the coil. So I'll draw the circuit again here. Resistor, coil, capacitor, and supply. Okay, 100 volt, 50 hertz. Okay, 10 ohms, 0.15 Henry. This is C. I we got, I is equal to 10 ampere. Okay, so they are asking what is the voltage drop across the coil. Okay, so what is the formula for voltage drop? V is equal to I into Z. Okay, this is a formula for voltage drop across the coil. So coil, in the sense, it is resistor plus 0.15 Henry, this is the coil, as well as capacitor. So this is the whole impedance. So we need the whole impedance. To find the whole impedance, Z, we have the formula Z is equal to root of R square plus XL minus XC the whole square. We know that XL is equal to XC. So it is Z is equal to R square plus XL whole square. So Z is equal to R, we know R is equal to 10 square. Okay, 10 square plus XL is equal to what XL we got? XL we got as 47.1239. Okay, that is 47.1239 whole square. So we'll get Z value as root of 10 square plus 47.1239 whole square. That is none other than 48.1732. Okay, we got the value of Z. Now voltage drop across the coil, V is equal to I is 10 into Z is 48.1732. That is none other than into 10. That is 481.7325 volt. Okay, we got the answer. So they are asking what voltage drop across the coil. What is a coil here? A coil has a resistance of 10 ohm and inductance of 0.15 ohm. So this is the coil. They want the voltage drop across this coil. So to find this, we need the equivalent resistance value, that is Z. So Z is equal to R square plus XL minus XC square. So they want only with respect to the coil. So this is a coil, that is XL square. So we are finding this and we got the voltage drop across the coil. So first we found out these values, and after that the voltage drop across the coil, current and the voltage drop across the coil. Okay, so if you have any doubt you can put it in the comment section. Let's go to the next problem. Hey guys, let's solve the second question of RLC circuits. So here is a question. A tuned circuit consisting of a coil having an inductance of 200 microhenry and a resistance of 20 ohms in parallel with a variable capacitor in series with a resistor of 8000 ohms across a 60 volt supply having a frequency of 1 megahertz. Calculate the value of C to give resonance, the dynamic impedance and Q factor, the current in each branch. Okay. So this is a question. Let's draw the circuit. A tuned circuit consisting of a coil having an inductance of 200 microhenry. So there is a coil, okay, which is having an inductance. This is of 200 microhenry, okay, and a resistance of 20 ohms. So there is a resistance of 20 ohms, okay, in parallel with a variable capacitor. So in parallel, this is in parallel with the capacitor, okay, okay. Capacitor value is not given. Let's consider it as C. In series with the resistor of 8000 ohms. So there is one series resistor is there, okay, that is 8000 ohms, okay, okay, across a 60 volt supply. Okay, there is a supply, that is a 60 volt supply, okay, volt supply having a frequency of 1 megahertz. So frequency is 1 megahertz, okay. Now calculate the value of C, that is the capacitance, to give resonance, okay. So first question is C is equal to how much at resonance. So at resonance we know that XL equal to XC, okay. We know the formula of XL. XL is equal to 2 pi FL. Okay, let's find XL. XL is equal to 2 into pi into F is 1 megahertz, that is 1 into 10 to the power 6 into L is 200 micro, 200 into 10 to the power minus 6. Okay, so it is 2 pi into 10 to the power 6 into 200 into 10 to the power minus 6. Okay, so that will be 1256.6371. That is equal to 1256.6371. Okay, this is XL. So this is same as XL. So at resonance XL is equal to XC. This is equal to XC. Okay. So now let's write XC formula. XC is equal to 1 by 2 pi FC. Okay. So we want C. So let's take C up. C is equal to, and bring XC down. 1 divided by 2 pi F into XC. Okay. Next one. C is equal to 1 divided by 2 pi. F is into 1 into 10 to the power 6 into C is 1256.6371. That will be equal to, okay, let's solve this equation. That is 1 divided by 2 pi into 1 into 10 to the power 6 into 1256.6371. That will be equal to 1.2665 into 10 to the power of minus 10 farad. Okay, so we got the value of C. Now the next value, that is we have to find the dynamic impedance of and Q factor. Okay, okay, next find out the dynamic impedance. Second question, that is the dynamic impedance. Dynamic impedance. Okay. So to find the dynamic impedance, there is a formula that is given as L divided by C into R. It is L divided by C into R. You know L is 200 into 10 to the power minus 6. Okay, C we got, that is 1.2665 into 10 to the power minus 10 into R we know it is 20. So the value will be, that is 200 into 10 to the power minus 6 divided by 1.2665 into 10 to the power of minus 10 into 20, that it is 78957.7576. Okay, this is the dynamic impedance. Next, let's find the quality factor, that is a Q factor. Okay, so there are two formulas for Q factor, so we'll get the answer same. So let's do with both the formulas. Okay, so first formula is Q is equal to 2 pi FL divided by R. Okay, 2 into pi into 10 to the power 6 into L is 200 into 10 to the power minus 6 divided by 20. Okay, that is nothing but 2 pi into 10 to the power 6 into 200 into 10 to the power minus 6 divided by 20. That is 62.83185. Okay, one more formula there, same answer we will get, that is Q is equal to 1 by R into L divided by C. Okay, 1 by R is 1 by 20 into root of L is 200 into 10 to the power minus 6. C is 1.2665 into 10 to the power of minus 10. Okay, root is there. Okay, so we'll solve that. 1 divided by 20 into root of 200 into 10 to the power minus 6 divided by 1.2665 into 10 to the power of minus 10. That will be 62.8322. Same, it's nearly equal, same 83. Okay, so we found out the quality factor. Next we have to find out the current. Okay, current in each branch. Okay, so I'll draw the circuit again so it will be easy for us. Okay, so let's draw the circuit. So we have a coil here, resistor, and there is a coil. Okay, the resistor, the capacitor in parallel along with the, okay, so we know this is 8000 ohm, 200 microhenry, 20 ohm, this is 1.2665 into 10 to the power minus 10 farad, this is 60 volt, 1 megahertz. So to find the current in each branch, so there will be flow of current, this will be I, this will be I. The current will split here, this will be I1, this will be I2. Okay, we have to find I1, I2. Let's first find I equal to how much? So by Ohm's law, V is equal to I into R. Okay, I is equal to V by R. What is V? V we know, that is 60. What is R? R is the total resistance. So what is the total resistance? That is 8000 plus, what is this total resistance? This total resistance is the dynamic impedance. So dynamic impedance we got, what is the value? That is 78957.7576. Okay, that is equal to 60 divided by 8000 plus 78957.7576. Okay, that will be equal to 6.8999 into 10 to the power of minus 4 ampere. Okay, 10 to the power of minus 4 ampere. So we got the value of I. Let's find out the value for I1 and I2. Okay. Okay. Let's find out the value of current I1. That is the second one. Value of current I1. So I1 is equal to V divided by Z. Okay, according to Ohm's law. So how to find Z? Z is equal to root of XL square plus R square. Okay. So we know the value of R is 20 square. Okay. Plus XL is equal to 2 pi FL. This we have already found out in the first problem while finding out C. So we have found out it's here. Okay. XL is equal to 1256.6371. So I'll write it directly here. That is 1256.6371. Okay, so we have to put it here. That is 1256.6371 whole square. Okay, Z is equal to, that will be root of 20 square plus 1256.6371 square. That will be 1256.7963 ohms. So now we have to find the voltage. To find the voltage drop across this. So we have to find the voltage drop across this. Okay. So to find that is equal to I into dynamic impedance. So this is the dynamic impedance. Okay. So I, what is total I? I is, we have found out, that is 6.8999 into 10 to the power minus 4. What is dynamic impedance? Dynamic impedance is 78957.756. So this will be nearly equal to 54.48007 volt. Okay. Now find out I1. I1 is equal to V divided by Z. We got 54.48007. Z we got as 1256.7963. That is equal to 0.04335 ampere. That is equal to 43.35 milliampere. Okay. Next find out the value for I2. Okay, third one. I2 is equal to V divided by Z. What is Z here? In I2, the Z is only XC. Okay. So that is equal to V divided by XC. So what is V? The voltage drop across this. It is same as 54 point same. Voltage drop will be same. In parallel, the voltage drop, if it is here, the voltage drop is 54. In parallel also, this will be the same voltage drop. That will be 54.48007 divided by XC. XC is this only. XL is equal to XC at resonance. So that will be 156.7963. That will be equal to same 43.35 milliampere. Okay, so we have found out this. Okay, I'll show from first which are the values we have found out. First, the value of C to the given resonance. So at resonance, XL is equal to XC. XL we have found out the value. Then XC, by substituting, we got the C value. Next one, dynamic impedance and the Q factor. Okay, so dynamic impedance and the Q factor is here. Okay, Dynamic impedance is equal to L by CR. L we know, C we know, C we have found out earlier, and 20 R. So we got dynamic impedance. Quality factor, same formula. Okay. Now current in each branch. To current in each branch there are three current. That is a total current, I1 and I2 current. Total current I is equal to V is equal to IR, I is equal to V by R. V is 60. R is the total resistance, that is 8000 plus dynamic impedance resistance. So we got the I value. Next, the individual I1 and I2. I1 and I2. I is equal to V by Z. So Z is XL square plus R square. XL square plus R square. We got the formula. I is voltage we have to find. That is I into total I into dynamic impedance. Voltage we got. I1 is equal to V by Z. Same. I2 is equal to V by XC. 43.35 milliampere. If you have any doubt, you can put in the comment section. I'll explain again. Okay, let's move to the next problem. So the question is, a circuit has a resistance of 3 ohm and an inductance of 0.01 Henry. The voltage across its end is 60 volt and the frequency is 50 Hz. Calculate the impedance, power factor and power absorbed. Okay, let's draw the circuit. So it is saying that the circuit has a resistance of 3 ohm. Okay, there is a resistance of 3 ohm. Okay, 3 ohm and inductance of 0.01 Henry. The voltage across its end, is 60 volt. Okay, so voltage is around 60 volt and the frequency is 50 Hz, that is 60 volt, 50 Hz. Now what they are asking? They are asking calculate the impedance. First is impedance. Okay, impedance. So we know that formula for impedance, Z is equal to root of R square plus XL square. So we know R is equal to 3 ohms. XL we have to find. XL is equal to 2 pi FL. 2 pi F is 50 into L is 0.01. That will be equal to 2 pi into 50 into 0.01. That will be 3.14159. Okay, so let's substitute this in the formula. Z is equal to root of 3 square plus 3.14159 square. That will be nothing but root of 3 square plus 3.14159 square. That will be 4.3439. Okay, so we got Z ohms. Okay, next let's go to the next question, that is the power factor. B, power factor. Okay, so power factor is formula is cos phi. Cos phi is equal to R divided by Z. We know R is 3, Z is we got 4.3439. Okay, that will be nothing but 3 divided by 4.3439. It is 0.6906. Okay, next is the power absorbed. Power absorbed. Okay, so for power absorbed, the formula is P is equal to VI cos phi. So V is equal to 60 volt, cos phi is equal to 0.6906. So to find I is equal to, according to Ohm's law, V by Z. V is 60, Z we have already found out, that is 4.3439. That is equal to 60 divided by 4.3439. That will be 13.8125 ampere. Okay, let's substitute that in this formula. 60 into 13.8125 into 0.6906, that will be equal to 60 into 0.6906, that will be 572.3336 watt. Okay, so this is the problem. So impedance you have found out by this formula, power factor and power absorbed. So if you have any doubt, you can put it in the comment section. Let's move to the next problem. Okay, let's go to the next question. A coil has a resistance of 4 ohms and an inductance of 0.00954 Henry. Calculate the power the coil will absorb and its power factor when it is connected to a 100 volt, 50 Hz supply. Okay, let's draw the circuit. A coil has a resistance of 4 ohm. There is a resistance of 4 ohm. Okay. Inductance of 0.05. This is 4 ohm and inductance is 0.0095 Henry. 54 Henry. Okay. And it is connected to a 100 volt, 50 Hz supply. Okay. Okay. 100 volt, 50 Hz. Now, what they are asking? They are asking calculate the power the coil will absorb and the power factor. So they are asking for the power factor is equal to how much and power is equal to how much. Okay. So we know that power factor formula, that is equal to cos phi is equal to R by Z. R is there already. R is equal to 4 ohms. So to find Z, Z is equal to root of R square plus XL square. So what is XL? XL is equal to 2 pi FL. That is equal to 2 pi into 50 into 0.00954. So that will be equal to 2.9971 ohm. Okay, let's put that in the equation. That is root of R square is 4 square plus 2.9971 square. Same as the previous problem it is. So that will be equal to 4.9983 ohm. Okay, Z we got. Now let's find the power factor. Power factor is equal to cos phi is equal to R by Z. So what is R? R is equal to 4. 4 divided by Z. Z is 4.9983. That will be equal to power factor is equal to 0.8. Okay, so we got power factor. Next they are asking what is the power. Okay, I'll do it here. This is for the power factor. I'll do for the power. Okay, we know power. Okay, P is equal to VI cos phi. Okay, V we know, that is 100. I we don't know. I is equal to V divided by Z according to Ohm's law. V is 100 divided by Z. Z we got here 4.9983. 4.9983. So what is I? I will be equal to 20.0069 ampere. Okay. Now let's find P. P is equal to V is 60. Sorry, not 60. V is 100 into I is 20.0069 into cos phi. Cos phi we know this already. We got what? 0.8 into 0.8. That is equal to 1601.0964 watt. Okay. I hope you got this problem. This is same as the previous problem. So first power factor. So for power factor, that is R by Z. Z we have to find, for that is R square plus XL square. XL we have to find by 2 pi FL. Then substitute in this equation and power factor we got. Then power. For finding out I, we have to do V by Z. Okay. Next, if you have any doubts, you can put in the comment section. So I'll go to the next problem. Okay, let's move to the next problem. So the next problem is the coils A and B are connected in series to a 50 Hz mains. The current is 1 ampere and the voltage across each coil is measured to be 45 volt and 70 volt respectively. When coils are connected in DC supply, the current is also 1 ampere but the voltage across the coil are now 20 volt and 40 volt respectively. Find the impedance, reactance and resistance of each coil, the total circuit impedance, the applied AC voltage and the power factor of the complete circuit. Okay. So the question looks big but the problem is simple. So let's solve this. So let's divide the question. First read the question properly. The coil A and B. A coil means it is a combination of a resistor and an inductor. Okay, there are two coils. The two coils A and B are connected in series. Okay, let's draw the coil. Okay, so it is a combination of a resistor and an inductor. Okay, so this is a coil A. Okay, next is the coil B. Okay, done. In series to a 50 Hz main, so it is connected to a 50 Hz mains. Okay, some AC supply is given and it is having a frequency of 50 Hz. Okay, 50 Hz. Okay, voltage and the current is 1 ampere, so the current which is flowing, that is 1 ampere here. Okay, voltage across each coil is measured to be 45 volt and 70 volt. So they are giving the voltage across the each coil. So this is coil A. This is coil A. Okay. And this is coil B. So they are given what? They are given across each coil it is measured to be 45 volt. This is 45 volt voltage. Voltage across this coil is 45 volt. And voltage across this coil is 70 volt. Okay, respectively. Okay, so this is for AC supply. Okay, let's solve for this one. Okay, AC supply, when it is connected with the AC supply. So what they are asking, find the impedance, reactance and resistance of each coil. Okay, this is for the first question. They are asking find the impedance, reactance and resistance of each coil. So they want impedance is equal to how much, reactance, that is the coil, so it will be XL, that is inductive reactance, is equal to how much, and the resistance, that is R is equal to how much. Okay, so let's find this out. Okay, first let's find the voltage drop. We know that the voltage drop across coil A. Let's go for coil A. Okay, coil A, what is given? In coil A, the voltage drop is given. Voltage drop of A is equal to how much? That is 45 volt. So according to Ohm's law, we know that V is equal to I into R. Okay, we know V, we know I. So R, what is R? R is a coil. So if it is a coil, it will be Z. V is equal to I into ZA. Let's take the impedance of coil A. So I am writing it is ZA. So ZA is equal to V. V is 45. 45 divided by 1 is equal to 45 ohms. We got the impedance of coil A. Let's go to coil B. Okay, coil B. Voltage drop of B, that is what, that is 70 volt. Okay, V is equal to I into R. It is not R actually, it will be coil, so it is I into Z. Okay, ZB. So ZB is equal to 70 divided by 1, that is equal to 70 ohms. So we got the impedance of coil A and coil B. Now we want the XL, that is the inductive reactance. So let's go do for the coil A. So what is the formula for inductive reactance? We know that ZA is equal to root of R square plus XL square. Okay. So to find XL, what is the formula will be? So XL will be equal to root of ZA square minus R square. I hope you got this formula how I did. I took the square root and I brought this equation this side. So you'll get this formula. Okay. So XL is equal to, okay, what is ZA? ZA is 45 square. What is R? R we have to find out. So R we don't know now. So but let's read the question properly now. Okay. When coils are connected in DC supply, the current is also 1 ampere, but the voltage across the coil is now 20 volt and 40 volt. Okay. Now, so we have already found out the voltage across the coil are now 20 volt and 40 volt. So to find this R resistance, okay, so now we don't know what is R, so it is R square. To find this R, we have to read the next question. Okay, for this also we'll write it down. ZB is equal to root of R square plus XL square. Okay, ZL is equal to root of ZB square minus R square. Okay, ZL is equal to root of 45 square minus R square. Okay, to find out this R, you have to read the next question. It is saying that when the coils are connected in DC supply, the current is also 1 ampere, but the voltage across the coil are now 20 volt and 40 volt respectively. Okay, let's continue this further. I'll continue it. So let's go for the DC supply. DC supply. Okay. So just remember, in DC supply, when a supply is given to a coil, it is same as a resistor. In DC supply, the coil is not a combination of coil plus inductor because there will be no change in the magnetic field. So it is a simple resistor. So the equivalent circuit for DC resistor, if it is a coil, it is same as a resistor. Okay. So coil A, coil B in DC supply. This is 1 ampere and the coil voltage drop they are given. This is 20 volt. Okay, and this will be 40 volt. This is coil A, this is coil B. Okay, and now we can find the voltage drop. So voltage drop at A, that is same. V is equal to I into R. This is just R. Okay, R1, R2. Okay. So what is voltage drop at R? R is equal to V is 20, 20 divided by 1 is equal to 20 ohms. R1 is 20 ohms. Now voltage drop at B, okay, that is V is equal to I into R. So R is equal to 40 divided by 1, that is equal to 40 ohm. Okay. So in DC supply, the coil is an equivalent resistor. It is not a combination of resistor plus inductor since there is no change in magnetic field. So it is a simple resistor. So we got the value of the R1 and R2. Okay. Now we got this value R1 and R2 in DC supply. So substitute these values here to find XL and XL, XLA and XLB. Okay. This is R1, this will be R2. Okay. Now let's substitute here. That is XLA is equal to root of 45 square minus what is R1? R1 we know it is 20 square. That is equal to 40.3113 ohm. Okay. Same XLB, that is equal to root of 45 square minus R2 is 40 square, that will be equal to sorry, it is not 45, I did a mistake here, it is 70. Okay, it is 70 square, I'm really sorry, it is 70 square. Okay, because ZB is 70. So 70 square minus 40 square, that will be equal to 57.4456 ohm. Okay, now let's go to the question now what they are asking. So they are asking the AC, in AC supply they asked for the impedance. So we have found the impedance ZA and ZB. XL reactance is found. So we got R1 by DC supply. Like in DC supply what the resistance we got, that we substituted here. Okay. So now we got XLR resistance also we got, and inductive reactance also we got. Now next question. Okay. The total circuit impedance. So they want the total equivalent circuit of both DC and AC circuit impedance they want. They applied AC voltage and the power factor of the complete circuit. Okay, let's solve that now. Okay, now they're asking for the total circuit impedance. So for the total circuit impedance, let's draw the circuit first. Total circuit impedance means they're asking the total resistor plus the total inductance, okay, and the total impedance of this, okay, that is connected to a supply of AC supply, okay. So this total impedance we want. So to find the total impedance, this will be RT and this will be XLT. So we know that Z is equal to root of R square plus XL square, okay. So what will be R now? RT. RT is nothing but RT is equal to R1 plus R2. What is R1? We got R1 before that, the value is 20 plus R2 we got it as R2 value is nothing but 40. So R2 is 40. That will be equal to 60 ohms. Okay. XLT is equal to XLA plus XLB. XLA and XLB we found out here. So that will be 40.3113 plus 57.4456. Okay. That will be equal to, one sec. That will be equal to 40.3113 plus 57.4456. Okay, that will be 97.7569. Okay, let's substitute this in the formula for total impedance, that is RT plus XLT. RT is 60 square plus XLT is 97.7569 whole square. That will be nothing but root of 60 square plus 97.7569 whole square. That will be 114.7014 So we got the total impedance. Okay. Next question. Total circuit impedance we got. The applied AC voltage. So according to Ohm's law, V is equal to I into R. But here it is a impedance, so I into Z. Okay. So we know V is equal to I. We know this is 1 ampere. It is given in the question. 1 into, what is Z? Z we found out, that is 114.7014. So the total voltage is also 114.7014 volt. Okay. Next question. The power factor of the complete circuit. So the power factor, that is power factor is equal to cos phi. Cos phi is equal to R by Z. R is what? R we got as 60. What is Z? Z is 114.7014. So that will be nothing but 0.5231. Okay. So we got this answer. All the problems have been solved of this. So I'll explain it once again. If you have any doubt, you can put it in the comment section. So for AC supply, so it is a resistor plus inductance. If it is a coil, so it is given a voltage drop is given. So we'll find out the impedance value for ZA and ZB and the whole 40.3113 and 57.56. So to find the resistor of this value, we have to use a DC supply. So DC supply will get R1 and R2. So that you are substituting here. Okay, so we got the impedance, inductance and the resistor. Now to find the total impedance is total resistor plus total inductance. So RT is equal to 60 ohms, XLT is equal to XLA plus XLB. So that we are substituting in this formula and we got the total impedance. Then the voltage drop by Ohm's law and the power factor. Okay, thank you. Okay, let's do the next problem. The next problem is find the frequency at which the following circuit resonates. Okay, so the circuit is already given, so it is a simple problem. So find the frequency at which following circuit resonates. So they're saying that the circuit is resonant. It means that at resonance. Okay, circuit is at resonance. We know that at resonance, the frequency is equal to F is equal to 1 by 2 pi into root of LC. I have discussed this formula in the first part itself. Okay. So we know that in resonance, XL is equal to XC and Z is equal to R. Okay. So let's see what is given in the circuit. There is given two resistors, all are in series. So we want the equivalent of L and equivalent of C. So let's solve the problem. Okay. So we need first L to find the frequency. L is what? LT, that is the total L, that is L1 plus L2. Okay. That is 0.1 plus 0.2 Henry, that is equal to 0.3 Henry. So LT we got. Okay. Next one, C, CT. Okay. When capacitors are in series, the formula is 1 by CT is equal to 1 by C1 plus 1 by C2. Okay. So 1 by CT is equal to 1 divided by 2 into 10 to the power minus 6 plus 1 divided by 0.5 into 10 to the power minus 6. Okay. So that is nothing but 1 by CT is equal to 1 divided by 2 into 10 to the power minus 6 plus 1 divided by 0.5 into 10 to the power minus 6. That is 2, 5, 1, 2, 3, 4, 5. Okay. So we want CT. So CT is equal to 1 divided by 2, 5, 0, 0, 0, 0, 0. Okay. It is nothing but 1 divided by, that will be equal to 4 into 10 to the power minus 7 farad. Okay, is equal to 0.4 microfarad. Okay. Let's find the frequency now by using the formula. F is equal to 1 divided by 2 pi root is 0.3 into C. C is 0.4 into 10 to the power minus 6. Okay. That will be equal to 1 divided by 2 pi into root of 0.3 into 0.4 into 10 to the power minus 6. That will be equal to 459.4408 hertz. Okay. So this is a simple problem. Okay. Let's move to the next problem now. Okay, let's go to the next problem. So the next problem is a heater of unit of inductance has a resistance of 6.5 ohm and is intended for use with 100 volt mains. For 50 Hz, what voltage would it be suitable when placed in series with the external apparatus of negligible resistance having an inductance of 0.01 Henry? If the frequency is raised by 5% and this voltage remains constant, what would be the resulting change of voltage at heater terminals? Okay, let's draw the circuit. A heater, unit of inductance. Okay, inductance means it is a coil plus resistance. So there is a heater, okay, that is of inductance and a resistance. Okay, inductor, this is a heater, okay, of 6.5 ohm. Okay, this is a heater. Okay, heater which is having a resistance, total resistance of 6.5 ohm. Okay, and is intended for use with 100 volt main. Okay, so it is having a 100 volt main, and for 50 hertz, what voltage would it be suitable when placed in series with the external apparatus? Okay, it is saying that it is intended for use with 100 volts main, so it means that the heater uses 100 volt, so heater's voltage drop is 100 volt. Okay, for 50 Hz, what voltage would be suitable when placed in series with the external apparatus of negligible resistance having an inductance of 0.01 ohm? So they're saying that if an inductor is placed, coil is placed, what will be the total voltage? Total voltage for 50 Hz frequency. Okay, so this inductor is of 0.01 Henry, and this hertz is 50 hertz. So we don't know the source voltage, less Vs and 50 hertz. Okay, so they are asking what voltage would be suitable when placed in series with the external apparatus of negligible resistance having an inductance of 0.01 ohm. So they are asking what is the source voltage that will be suitable for this heater plus inductor. So this is a source voltage. There will be some current I flowing in this. Okay, so let's write what is given. So we know that the voltage drop at heater is equal to 100 volt. So by Ohm's law, V is equal to I into R. So we know that is 100 is equal to I. What is our resistance of the heater? The resistance of the heater is given as 6.5. So I is equal to 100 divided by 6.5. Okay. So 100 divided by 6.5, that is 15.3846 ampere. Okay, we got this I value. Now they are asking what is the source voltage. Okay, to find the source voltage, that is Vs is equal to I into Z. This is the formula. We got I, now we have to find Z. So to find Z, Z is equal to R square plus XL square. So XL, to find XL is equal to 2 pi FL. So what is 2 pi into 50 into L is 0 0.01, 0 0.01. So it will be none other than 2 pi into 50 into 0 0.01. That is 3.14159. Okay, so Z will be, Z is equal to root of R is 6.5 square plus 3.1415916. Let's write it as 16, round it up, square. Z is equal to root of 6.5 square plus 3.1416 square. That will be 7.2194 ohms. Now let's find source voltage. Vs is equal to I is given, that is 15.3846 into 7.2194. That is none other than into 15.3846. That will be 1110.675 volt. So we got the source voltage. Okay. Now next question. If the frequency is raised by 5% and this voltage remains constant. So second question, they are saying that frequency is increased by 5%. Okay, increased by 5%, and the voltage remains constant. So Vs, that is the source voltage, remains constant, that is 111.0675 volt. What would be the resistance change of voltage at the heater terminal? So they are asking the heater terminal voltage, Vh. So if the frequency initially f is equal to 50 Hz, now it is increased by 5%. So it means that for 50 Hz it is 100%. Now it is increased by 5%. 105%, how much it will be? So that is 50 into 105 divided by 100. That is 52.5. So now the actual frequency is 52.5%. Okay. 5 Hertz, not percent. Sorry, 52.5 Hertz. Now you want the heater terminal frequency. So to find the heater terminal voltage, so we know that is VH is equal to I into R. Okay. R we know, R is equal to 6.5 ohm, it is already given. So we have to find I. I is equal to voltage in the source divided by Z. Okay. Source voltage we know, that is 111.0675. Z we will change. Z is equal to root of R square plus XL whole square. Okay. XL is equal to 2 pi FL. Now F has changed, 2 pi into 52.5 into 0.01. So that will be another than 2 pi into 52.5 into 0.01. That will be 3.2987. Okay. So Z will be root of 6.5 square plus 3.2987 square. Okay. So Z is equal to root of 6.5 square plus 3.2987 square. That will be 7.2891. Okay. Now let's find I. So I is equal to 111.0675 divided by 7.2891. That is 15.2375 ampere. Now let's find voltage at the heater terminal, that is I into R, that is into 6.5. That will be 99.0436. Okay, volt. So we got the voltage of the heater terminal. So it means that as frequency increases by 5%, voltage decreases of the heater. So this is a problem which we did now. So if you have any doubts, you can put it in the comment section. I'll solve the problems again if you have any doubts. So, and if any problems are remaining, I have not completed it, you can also put that question. I'll try to solve that problem. Okay, thank you. Next video will go to the next topic.